This is 2018 AP Physics2 FRQ. Students are given resistor 1 with resistance R1 connected in series with the parallel combination of a switch S and resistor 2 with resistance R2 as shown above. This is the circuit given to us. The circuit elements cannot be disconnected from each other, and other circuit components can only be connected at points A and B. These are the A and B. The students also are given an ammeter and one 9-volt battery. The teacher instructs the students to take measurements that can be used to determine R1 and R2. A bit. Complete the diagram below to show how the ammeter and the battery should be connected to experimentally determine the resistance of each resistor. Describe the experiment by listing the measurements to be taken and explaining how the measurements would be used to calculate resistance as R1 and R2. Here we have to complete the circuit diagram and then describe the experiment. And then next, they are giving the next question, next bit. A second group of students is given a combination of circuit elements that is similar to the previous one, but has an initially uncharged capacitor in series with the open switch as shown above. Here, along with the switch, they connected an uncharged capacitor. That is the difference between the previous one and this one. This and this. Okay. The combination is placed in a circuit with a power supply so that the potential difference between A and B is maintained at 9 volts. The students close the switch and immediately begin to record the current through point B. The initial current is 0.9 amps, and after a long time, the current is 0.3 amps. Compare the currents through the resistor 1 and resistor 2 and the switch immediately after the switch is closed to the currents a long time after the switch is closed. Specifically state if any current is 0. Calculate the values of R1 and R2. Determine the potential difference across the capacitor a long time after the switch is closed. Next bit. A third group of students now uses the combination of circuit elements with the capacitor. They connect it to a 9-volt battery that they treat as idle, but which is actually not idle and has internal resistance. How does the third group's value of R1, calculated from the data they collected, compare it to the second group's value? Explain your reasoning with reference to the physics principles or mathematical models. Here, we are given the circuit. In this circuit, cannot be dismantled. It should be connected to the other components. The main of this circuit is to calculate R1 and R2. That is the reason for the circuit. Determine R1 and R2. And then the voltage of the battery, one 9-volt battery is supplied to us. So here ammeter is given to us to measure the current. So to measure the current, we have to connect the ammeter in series, obviously. So we are connecting, this is the ammeter, and we are connecting the ammeter in series with R1 and R2. And then the battery is also connected in series. Okay, both ammeter and battery are connected. DC supply are connected to the this given circuit in series. Okay. Now we know, according to Ohm's law, V is equal to IR. Therefore, I is equal to V by R. When the switch is open, it is a series circuit. R1 and R2 are in series with each other. And then therefore, the total current flowing through the circuit is voltage divided by current. Am I right? Here, voltage divided by resistance. The resistance is the total resistance because in series, both will add up. Therefore, I is equal to V by R is equal to 9 volts divided by R1 plus R2. When switch is open, remember. Okay. And when switch is closed, what happens? The current will not flow to R2, but flows through the switch because the switch has no resistance at all. Therefore, it flows through the switch. Okay, therefore the current, when the switch is closed, the current is equal to voltage divided by the only first resistance. This resistance is shorted, no? Therefore, the current, because of the switch closed, the current will not flow through the resistance R2. It will be going through the switch. Therefore, this is the equation. So from these two equations, because we know I, and then we can calculate the values. From this, R1 can be calculated. From the value of this one, R2 can also be calculated. Okay. That is how we can calculate. And then next, next what happened? The teacher gave another circuit in which, along with the switch, a capacitor is there. Okay, that means this is a parallel RC circuit. R2 and the capacitor are parallel to each other, and then the circuit is series with the R1. Okay, and then here what happens? The capacitor is not charged initially. Okay, and then the voltage of the battery is 9 volts only. The DC supply is 9 volts only, and then initially the teacher gives the initial current as 0.9 amperes, and then long time after closing the switch, the current is 0.3 amperes. Okay, so what does it mean? What we have to do now, we have to calculate R1 and R2, and then we have to find out if at all there is a zero current in any part of the circuit. That is what he is asking. Specifically state if any current is zero. Okay, and then determine the potential difference across the capacitor a long time after the switch is closed. These are the values we have to give, numerical values we have to give. So initially what is happening when the switch is closed, soon after closing the switch, the current flows through the resistor R1 and through the capacitor. It will not flow through R2 because the capacitor is not charged. It has zero resistance. When the resistance is zero, obviously the current flows through R1 and through the capacitor. At that point, the initial current is 0.9 amperes. That means we have to equate V is equal to IR. No, so voltage is equal to 9 volts, and then current is 9.9 amperes, and then we have only one resistor. Okay, so therefore R1 is equal to 10 ohms. From this, we can calculate R1. After a long time after closing the switch, what happens? The capacitor is fully charged. Once the capacitor is fully charged, this becomes open. So the current no longer flows through this part. The current has to flow through R1 and R2 and B. Okay, so therefore the voltage 9 volts is equal to, here the current is given as 0.3 amps. So 0.3 ampere IR, no, V is equal to IR. Therefore 9 volts is equal to 0.3 times R1 plus R2. We already found out R1, and then R2 we can find out. So here, substituting that value, we can find out R2 is equal to 20 ohms. Here he is asking specifically state if any current is zero. So here what happens, after a long time after closing the switch, the current through the capacitor becomes zero. Okay. Soon after closing the switch, the current through R2 is zero. After a long time after closing the switch, the current through the capacitor is zero. So that is the one here. And then we calculated R1 and R2. Next, determine the potential difference across the capacitor a long time after the switch is closed. See here, R2 and capacitor are in parallel with each other. Therefore, whatever the voltage drop across R2, the same voltage drop we have at the capacitor. So voltage drop V is equal to IR. Am I right? So when V is equal to IR, here I is equal to, after a long time, the current is 0.3 amps, and then the resistance of R2 is equal to 20. So this is equal to, the voltage is equal to 6 volts. Like this we can calculate. There is another way to calculate the same thing. That means we know the total voltage of the circuit is 9 volts. DC supply is 9 volts. 9 volts minus this one. Here, I think I wrote here. Wait a moment. Yeah. V capacitor is equal to V battery minus V across R1. So battery is 9 volts, 9 volt battery. And then voltage across R1 is IR. No, here I is 0.3 amperes because after a long time the current is 0.3 amperes and then resistance is 10 ohms. Therefore, this is 3. 9 minus 3 is equal to 6 volts. Okay, so this is another way to calculate the voltage across or potential drop across, voltage drop across the capacitor or the potential difference at the capacitor. Okay. Now the third bit. A third group of students use a combination circuit elements with a capacitor. Okay, this kind of thing. They connect it to a 9-volt battery that they treat as idle, but which is actually not idle, has an internal resistance. Okay, so when the internal resistance is there, what happens? The total resistance of the circuit will be higher. Am I right? See here, initially the total resistance is R1 plus R2 because the circuit is idle. Okay, that means the battery has no internal resistance. We consider that the battery has no internal resistance and then therefore it has the total resistance of the circuit is R1 plus R2. But here, what is happening? The battery has some internal resistance. When the battery has some internal resistance, what happens? That will come into picture. And when another resistance is there, the total resistance of the circuit will be greater than R1 and R2, or R1 plus R2 by a factor R. Internal resistance is lowercase r. Hence, R1 calculated by the third group will be higher than the second group. Obviously, no. That's it. That is the answer for this question. Hope this helps. This is simple. First, if you know where to connect the ammeter, that is the first thing, because we should connect the ammeter in series. Whenever we are connecting the ammeter in a circuit, it should be in series to measure the current. Okay, ammeter measures the current and then it should be in series with the other components so that the same current flows through the ammeter and then we can measure the current. That the thing you should know. And then the rest of the things you should know the behavior of the resistor and capacitor when they are connected in parallel. Soon after, if the capacitor is an empty capacitor, that means the totally discharged capacitor or not at all charged capacitor if you are connecting. Soon after closing the circuit, the capacitor acts like a switch and then with a zero resistance and then the current flows through the capacitor. After closing the switch, after a long time, the capacitor gets fully charged and the current no longer flows through the capacitor. Okay, so here he asked where the current, if specifically state if any current is zero, means the current is zero soon after closing the circuit at R2. Okay, because the resistance is more, the current will not flow through R2. And then after a long time, the current will be zero at the capacitor. And these things are important in this answer. Okay, hope this helps. Thank you. Bye-bye.